Alright, first section, limits algebraically. Pretty simple if you've taken algebra before. If you haven't, you shouldn't be in this class. Anyways, this is the notation for limits. Limit as x approaches some number. It can be any number in the world, it's gotta be some number. Of this equation. I put blah there, but this is the equation. So as you can see, there's multiple equations right here. It can be anything in the world, and you're probably gonna need a multitude of them. But let's look at a simple one. How do you solve them algebraically? Well, the simplest and the one you're gonna hope for the most is limit as x approaches 2. Can be any number here, but you can just plug it in. And if you plug in x equals 2 here, you're gonna get 5 times 4, because that's 2 squared, plus 2, which is 22. Oh, look at that, you solved it. It's simple, yeah. Limit as x approaches 0. Now you've got, what do you do here? You got a division, same thing.
You plug it in.
0 plus 1 equals 1 over negative 1 equals?
Negative 1.
Pretty simple, right guys? Now when you have this, and you try to plug it in, you got x approaches negative 2. If you try to plug that in, you're gonna get over 0, and that's undefined. Can't do that. So what are you gonna try to do? First step you want to do is you're gonna see if you can unravel that, or
factor it.
Defactor, right?
Unfoil it.
Unfoil it. And you're going to try to make something out of it. And actually, this one becomes out to be x plus 2. X plus 2 over x plus 2. And since you know how to do algebra, since you're in AP Calculus, you can knock those out. Plug in a negative 2, and this equals 0. Now, it's not undefined, but it's still, as x limit approaches negative 2, it's going to look like it's hitting 0. Now, as a limit as x approaches 2, you can't plug in 2 here, you're going to get 0 again. So we're going to
do that.
You're going to do the same thing.
And factor that out.
X plus
difference
2.
of perfect squares.
Yeah, oh yeah. And you're going to get x minus 2.
And bam, gone.
Bam, and you're going to get 4. Look at that. Now, you need to understand first, we just taught you how to do it and without what it means. If you're looking at a graph here, and here's 2 on the y-axis, and the equation goes like this, just of crazy sorts. If I asked you, as the limit approaches a certain number, it means from the left and the right what number is it hitting. In the next section you'll learn how to look at it on graphs. But the limit basically saying is, as it approaches that number, what does it look like it's going to hit? And you're going to see cases when there's not going to be an answer, which is the algebraic ones. You can't look at it answerly, because if I'm giving you x squared plus 5x plus 27, you can't unravel that, and there's like x minus 2 at the bottom. You can't solve that algebraically if it's trying to go to 2. You'll learn about graphs in the next section when you can look at a graph and tell where it's about to reach. But until then, have fun learning limits algebraically.
There you go.